All right, so this is 90-1. We're going to work on the DI. So for number 1, for this one we'd have to use the substitution method because it says x plus 2y equals 5, x equals 6. Substitute it in, so I get 6 plus 2y equals 5, minus 6 on both sides. Now, my answer is a point. So even though I have my two values, leaving it like this is unacceptable. We have to write it as 6, negative 1/2. Number 2. So there's that 4 in the denominator. I want to multiply both sides by 4 to get rid of it. Multiply both sides by 2. So I get x plus 2y equals negative 20. And then I get 3x minus y equals 2. And now I can use the elimination method. So I'll multiply this entire row by 2. So then when I add these together to create a new equation, and then you can go ahead and work on it from there. The next one that I want to take a look at just real quick for number 4, I'm just going to look at the top equation. So sometimes we're going to get values, like for example this 2 that's in the denominator. Remember, we can multiply the entire equation by value if we wanted to get rid of it. So if the fractions are making you feel, I don't really want it, if you multiply everything by 2, 6y, well then this is going to become negative 6 over 2, which is the same as negative 3, and then negative 15. So remember, you can multiply the entire equation by a value to get rid of it. So whenever we get these, just know that they're going to kind of simplify nicely. I know they look a little complicated, but just kind of trust in what we have to do. For example, I see that I have a negative exponent. Well, I don't want negative exponents, so what I need to do is I need to make them positive. So that'll be the first thing that I do. That 3 is still on the denominator. So on top, I have x to the 3/4. On the bottom, I have 3 times x minus 3 to the 2/3. And then plus, that 3 is on the top here. This x minus 3 to the 1/3 is on the top. And on the bottom, it's 4 and x to the 1/4. Now for me to be able to combine these together, I do need to find the common denominator. So this has a 3 in the denominator, so this needs a 3 over 3. This has an x minus 3 to the 2/3 in the denominator, so it needs an x minus 3 to the 2/3, top and bottom. Now on this side that has a 4, so this needs a 4 over 4. And then this has an x to the 1/4, and so this needs an x to the 1/4 over x to the 1/4. So now they all have the same factors in the denominator. They all have 4's, they all have 3's, they all have x minus 3's to the 2/3 and x to the 1/4. So now cleaning this up. On top on this side, I have 4 times x. Now if you're wondering why is it 4 times x, because this is 3/4 and this is 1/4, well I have to add those together. 3/4 plus 1/4 is 1. Plus 3 times 3, so I'll just say 9. And then that'll be x minus 3. 1/3 plus 2/3, that just turns that into a 1. And then all over, I have 12 x to the 1/4, x minus 3 to the 2/3. That's all less than 0. So remember, now we need to find the undefined values and the zeros. So for the undefined values, you have to look at the denominator. So for the undefined values, or the domain restrictions, I have x to the 1/4 cannot equal 0. And then I have x minus 3 to the 2/3 cannot equal 0. So that means x can't equal 0 and 3, because you set each of those equal to 0 and you solve. So those are some values. The other thing is the 1/4. Well, that's going to be the 4th root of x. Well, that's an even root. So that also means x can't be greater than or equal to 0. So that's, or can't be negative, so x can only be greater than or equal to 0. So we need to think of these simultaneously together. Now my zeros. All I have to do is set the top. So 4x plus 9x minus 27, that's 13x minus 27. Add 20, and this all equals 0. So add 27, divide by 13. So you get x equals 27 over 13. So now on the number line, we have x can only be greater than 0. So at 0, this is all undefined. I don't have to test it. Now here it says it can equal it, but here it says it can't equal it. So open circle. I also have an open circle at 3. And then at 27 over 13, we'll say that that's right here. That's also an open circle because it can equal it. Because it says right there, my zeros are open circle. So I have to test these 3 regions here. And because it's less than or equal to, I'm looking for negatives. Now I'm going to allow you to test it. I did all the hard work here, but I'm going to allow you guys to go through and test that. So for number 9, we have x to the negative 2 minus 6x to the negative 1 plus 9 equals 0. This is going to be that u substitution. I can rewrite this as x to the negative 1 squared. So if I say u equals x to the negative 1, then this becomes u squared minus 6u plus 9 equals 0. And then from there, factor and solve. Let's look at another one. So, let's look at number 11. So x over x squared plus 1. It says identify the horizontal asymptote or the slant asymptotes. So we have to compare the degrees. The degree on top is 1, the degree on bottom is 2. So since the bottom is larger, it's automatically y equals 0. Number 13, 2 tangent of 1/4 x minus 3. So I have to take the 1/4 x and put that between 0 and pi. Solving for this, I'm going to get 0 is less than or equal to x, which is less than or equal to 4 pi, because you multiply everything by 4. Do the box. 0, 4 pi. Add the ends, divided by 2. 2 pi. Dad helps us graph tangents. And so plotting this, we know that we're going to have the center line move down 3. And then we need it says 2 cycles, so this is going to keep going. And so we're going to have dot asymptote dot asymptote dot, oops, and there's tangent.